All right, now we're recording. Thanks. Cool. Okay, so first thing I want you to do is do like a 5-minute research brainstorm, and on the mirror board, put down a definition of encapsulation. So literally no more than 5 minutes. I might even shorten it to 4 minutes. Go find a description as applied to programming. What is encapsulation? And just whack it down on the mirror board. Now, even if it's like an entirely new concept, find something that you feel like might represent it. Even if it's nothing, we're going to start from somewhere and then we'll come back to it at the end. What is encapsulation? Just another 2 minutes. One more minute. One more minute. Okay, so let's read through them really quickly. I think some of them are similar. I'm going to start at the top left and we'll go through them. Encapsulation refers to the bundling of data with the methods that operate on that data. Encapsulation is used to hide the values. I can't see the rest of it because guest Nero Hero is hovering over it. Next to it, encapsulation refers to the bundling of data with the methods that operate on that data. So I think that's a repeated one. So I'm just going to put this, oh, no, right, let's figure out how to make that. hopefully that now works. Yes. Okay. So that's a repeated one. Whoever that is, I've chosen. You're the chosen one. Okay. Bundle data methods, clearly defined entry point to class, keeping some variables private, so user should not access them directly. That's an interesting one. I might put that over there in a second. Holding data, for example, in a class where you can also create methods, that can manipulate this data. Yeah, it reduces the amount of code you need to write by reducing the need for repeated code. Encapsulation refers to the bundling of data along with the methods. The process of binding the data with the functions that act on the data. Cool. Combine data and methods. In a class of encapsulation in computer science that it consists of data and methods embedded on a single unit, restricting variables, methods to local scope and protecting economic access. All right, cool. I'm going to move this over here. I like this one as well. A way of incorporating both methods and variables into one unit in order to make object-oriented programming easier. Encapsulation is one of the fundamental concepts in object-oriented programming. It describes the idea of bundling data and methods that work on the units. And this lovely one in the middle, encapsulation refers, it's fundamental object OOP, encapsulation, cool. Okay, I think that's all of them mostly. Cool. Okay, so probably some of these things are like, words that we don't really understand just yet. But we're going to focus on this one here, and we'll come back to this part of encapsulation later. There are two main definitions, or two main parts of definition of encapsulation, and we're going to focus on this one here today. Okay, so let's think about this in the context of a program and give some context to different paradigms of programming. So if we think about a program, when we run a program, is essentially living in the context of what's a good metaphor? Maybe like a world. Let's go with that. So imagine the world exists like this, big box. This is your program. For example, let's use to sort of flesh this out or to see it visually. If I run a program, let's say I go into my node environment and I have a look at what is the current world that I exist in. I can just type in this. This refers to the current scope. So you can think of a world like synonymous to a scope. What's the current scope? What's the current world that we're in right now? In the moment, we're at this sort of global level. So if I defined a function at this level, it exists at this scope. For example, if I did function hello, let's just give it a return value. And then I had a look at what this is again. I can see I've actually added a function to this scope, this world. This function now exists at this level in the world. And so I can say here that I've now added in my global scope, or in this scope, I've added a function. Hello. Now imagine this scaled like to lots of functions at this one scope, and loads and loads of scope, loads, like I don't know, hundreds of functions at this scope. Things can get quite difficult to figure out in two ways. One, which functions are doing what. Maybe it's not just functions that we have, which is what we call program behavior, things that it does, but there's also another part to this, which is the values, or what we call state. The things that we store, like variables, values and variables that we're storing. And if we keep everything in one scope, we're going to litter this one world with lots and lots of things. So we'll have loads of functions at this one scope, and we'll have loads of variables holding bits of data that we need. And object-oriented programming came along to try and organize this as a way of organizing the complexity of large programs with lots of functions and lots of variables all in one scope. All right, that's one world. So encapsulation is this idea. We're going to say we're going to figure out a rule that says, all right, we're going to try and organize this complexity and put it into boxes or smaller worlds. So we can't access these functions directly at the one scope. We have to create smaller scopes. So, for example, we might want to create a box here and move that function to be inside of this box. Maybe also with some state. And you can see that we could repeat this pattern a lot. So we can start to organize the one scope into many scopes, or one world into many different worlds. But still the question remains, how? Like, what is the rule that we're going to do this by? And the most common way to do this is to think about responsibility. Or another word for this is cohesion. All right. Cohesion is the idea that in one scope, things should be very similar. All right. They should be doing this or acting in this in roughly on the same bit of data or doing the same kinds of things. And so we try to strive for this idea of high cohesion rather than low cohesion. Low cohesion would be like what would be in one scope. Lots of functions doing lots of different things all over the place. That's very low cohesion. So we're going to have a look at it as some examples, very simple examples, which is try and really just play around with this idea of encapsulation as a way to group similar functions, all right, similar in that they have similar behavior, so that we come out with encapsulated program behavior. So we get functions from one scope and variables or state from the same one, and we try and put them into the same box. All right, where the rule is we're trying to find things of high cohesion together. Cool. Okay, so one idea that we have so far is without object-oriented programming, we have lots and lots of functions and variables that hold data all in one scope, and it can get quite messy to figure out what's doing what and what needs to change. So object-oriented programming's approach to this is to say, all right, let's break this up into high cohesive boxes or encapsulations of program behavior. And a class is a very convenient way to do this. It's not the only thing that allows us to encapsulate things, but it's very convenient. And we're going to have a look at some examples using classes to encapsulate program behavior. Let me just pause there for just thoughts or questions at the moment. So far, so good. Just give me a quick thumbs if it's like, yeah, broadly making sense. Yeah, any thoughts or questions at the moment? All right. So you'll hear me refer to behavior and state a lot. All right, behavior and state comes out of this paradigm of object-oriented programming. Now, the other paradigm is functional programming, and we'll borrow some of the ideas of functional programming during the course, and then we'll focus a little bit more halfway through, so towards the end of the course. Functional programming tries to organize complexity slightly differently, but it's they're not necessarily exclusive, but they can be worked together. So we have behavior, and behavior is this idea of what does a program do, right? And usually they're quite synonymous with functions. Functions do things. They take in inputs and they give you outputs. So behavior is something that we think about a lot in programs. What is the behavior of my program? And state is the values that we need to hold. As a general rule of thumb, try and keep as little state as possible. Right? The more state you hold, the more likely it is that you'll introduce bugs. Right? Things need to persist in memory. You might need to change values, and the more changes that are possible, the more likelihood there might be bugs. So where possible, we keep as little state as we can. And that's something that we'll think about a lot in how do we manage these things. But this will mostly be for the next module when we think about software design. All right, this is trying to really introduce us to the idea classes as a way to encapsulate program behavior, moving from procedural programming, just writing lots of functions, to organizing these functions into classes. Okay, so let's have a look at our workshop. So some of you have been in that sort of description encapsulation. We're thinking about maybe subconsciously answering this question: what is an object? And we'll come back to this progressively through the sort of first part of the course, because there's some interesting answers here about what is an object, literally, metaphorically, especially in object-oriented programming. But let's focus on cohesion. So I talked a little bit about it. Each class should have one purpose, sometimes referred to as its responsibility. Right? In sort of software design, we think of single responsibility principle as part of the acronym. But I guess we'll come back to, where's my Miro board? Over here. There's an acronym that we'll come back to a lot, which is, and you might have heard of it, has a nice name called SOLID, right? And this one here, the S, stands for single responsibility. And that's something that we've been discussing, right? Classes should have high cohesion and be responsible for one thing. And the idea of trying to figure out what is the one responsibility of the thing, we'll get better at in time. So as applied to this example, we want to be able to think about our classes as having one purpose or job, and a class that has high cohesion means that there's nothing left to remove. Everything in it is very cohesive. So let's have a look at how we think about this. Let's take this example, my square. Let's imagine we wanted to group these methods by how related they seem, the idea of cohesion. All right, you might come up with some kind of diagram like this. All right, this is just a simple representation. Maybe it's a little bit bigger. And if you have a look at sort of the functions, we have a perimeter function that just returns the perimeter. I did this quite quickly, I think that's correct. It's just a square, yeah. Area is another function. Summary just creates some output to your console with the information about the shape. And then we have another function that logs a string. Now, this is quite a contrived example, but you can say clearly that there's one function at least that sticks out, right? It doesn't really belong in this class. So the way that we would resolve this, if we're trying to think about a well-encapsulated class, is to regroup the methods into two classes. We extract it and build its own class, right? Quite contrived, quite simple. But this is just trying to think about the idea of looking at a bunch of methods and really thinking about how cohesive they are. Good morning, Sophie. So, any thoughts about just like that simple sort of a difference between going from this class to this class, set of classes? All good so far? Yeah, some nods and thumbs, yeah. Okay, so first exercise, and I'm gonna pair you up in a second, but I want you to just very quickly, no more than like 5 minutes, use that same kind of diagram. You can just chart it however you want. There's no real axes here. It's just literally just proximity to sort of think about which methods are related to each other. So if you want to have a different version of this, just try and diagram it somehow. These two different scenarios. All right. There's nothing else apart from the method signature, so what the method says and the arguments to sort of roughly do this. I'm not looking at anything too advanced. Just have a good go quickly in your pairs, and I'll release them in a second. Excuse me, to diagram these two things. All right, 5 minutes. I need to send out the pairs. I always forget. Cool. And given that, who's going to be Mary Poppins today? Lewis, you're going to be Mary Poppins today, all right? Sound good?
Yeah.
Awesome. All right. I will put you into breakout rooms because we'll come back a few times, and it shouldn't take that long at all. And I might ask you maybe. No, let's come back after that. All right. Let me set these up. Breakout rooms. This is the frustrating thing. I have to do it manually because I've already done it. No, I'm going to do it. I'm going to assign you automatically. So ignore those pairs. You'll do those pairs in the afternoon because I don't want to have to do this manually. So I'm going to create it automatically with everyone on the call. All right. All right. 5 minutes. Off you go. What? No. Yeah.
Talk about it.
Guys, I didn't want to expect it. It said there was like 8 rooms, but clearly not. All right, let's try that again. I'm going to leave the room. Happy Monday. Silly Zoom. Really, it's just user error. It's just me. We have to wait 40 seconds. Everyone understand though what they have to do over the next 5 minutes? Cool. So just diagram, either choose a space on the Zoom board and create your own little space, or just do it together. But just come up with some kind of visual representation of the relatedness of these methods, and then we'll move swiftly on to the next exercise. All right, let me try this again. Recreate. I want 8 rooms, assign automatically, and recreate. All right, so far so good. Let's try it again. Welcome back, welcome back. How do you guys diagram or visualize it? What did you do?
On a trusty sheet of paper.
Nice. Yeah. Is it visible if you hold it up to the camera, old fashioned? Oh, look at that, cool. Yeah. Welcome back, thanks. Okay, quick questions before we move on to the next part. Anything that rose to the surface as you were doing that? Any thoughts?
It was quite difficult to categorize them because we didn't know what they did.
So how did you make the choice?
Sorry?
How did you decide?
We sort of made a logical guess at what they did because credit account and debit account have the same input, so they probably do a similar thing with different accounts in the bank. Get balance probably just gets the balance of overall account, so that would be separate, and print statement would print all the details. We didn't get to number 2.
Cool. I'd love to see more, maybe the examples of bank. So does anyone have a version of maybe let's start with you, Lewis. Do you have a way to like show us, or do you want to just talk through it, how you thought about the relatedness of those methods?
Yeah, I'm not sure. We just sort of thought about the inputs, and they possibly did in relation to like what are you actually asking?
Yeah.
What are you actually asking for when you're asking for a credit account and you're putting in the date and the amount? But beyond that, I'm not really sure how.
That's exactly right. So that's all. I don't want you to think too much about it. Just look at the names, the methods, the arguments, and sort of like have a feel for how related you think they are. Did anything stand out to you as being like really related or not really related?
So the ones that take the same input would be the most related.
Cool.
Yeah, that's probably about it.
Cool. Anyone else have any thoughts about what was related and what was not related for the bank example?
See, I'd argue they're all related because without adding funds into the account, then you can't really get a balance or print a statement. So I'd chuck them all in the same class. I mean, they may not take arguments, but they all rely on each other to function.
Potentially. Anyone else have any thoughts?
Maybe print summary is slightly separated from the other 3.
And why do you say that, Ritu?
Because print summary is just a description of the kind of the snapshot of the account, but the others actually manipulate the account. But then again, get is a bit separated from the other 2, because get also is kind of a snapshot, but the other 2 really manipulate the variables inside the class. So I would not say that they are very separated, but so our group thought that maybe credit and debit are very near. Get balance is a bit separated, and print is a bit separated too, like that.
Yeah, there's no real right answer here because, as Lewis pointed out, we don't really have enough information, right? But what we can go on is start to think about some of these differences, and that feels like it makes some sense. Anyone else have any thoughts on this? The relatedness of methods in bank.
So we assume that credit account and debit account means adding money or subtracting from the account and not creating a new account.
Okay, that's fine.
Oh, okay. That was what we were thinking. Not like creating a new account.
Any other thoughts or questions?
So, yeah.
Okay.
Cheers. If we regroup these methods so everything does do like one thing really well, what is it that makes that like almost better in terms of like making our code better? Why is not having everything that manipulates like a certain like variable or data in one object a better way to think about it?
So there's a trade-off. There's a trade-off in having everything in one place to look at, and the number of files and folders that you need to sort of break things up. All right. So there's always going to be a trade-off in the sort of legibility or maintainability when we start to break things into separate pieces and where we keep them. But over time, complexity increases, right? So this contrived example of 4 methods, clearly, you don't need to do too much to it if you want to keep it all in one place. But that doesn't happen. So this is an example of what happens when you have like a class that has like 100 functions in it, and we have to think about like, well, what happens then? What are some convenient ways to think about breaking up a class according to cohesion? All right. If you have everything in one class, it can be hard to understand because your brain can only hold so much essentially information or context in one place. And if you have lots of state and lots of functions in one scope, and to figure out what's breaking or what's working involves a lot of mental thought. And where possible, I know that it's the old adage that programmers are lazy, but it's actually a really useful one. All right, we have to try and minimize cognitive load. So trying to make things really small, simple, and responsible is a lot tougher than it sounds. Simplicity is a really key and defining factor of experienced software engineers. And part of that is breaking things into small pieces. All right. So I think this is a really important question to keep thinking about and asking. And this is not something we're going to resolve today, right? And the idea of like, why does this make it easier, right? We have to probably experience pain before we can start to understand the value of some of these things, right? And that's why in lots of schools of sort of like training, we don't really teach refactoring until you've experienced the pain of unfactored code, because then you don't really understand the value of it. But the thing is, there's lots we can do during training for this. Cool. So some of what I've heard is let's keep everything in one place. Print statement feels a little bit more of an outlier. Credit and debit account seems similar. And get balance seems similar, but not as similar as credit and debit. And these are all good things to think about. What about the secret diary example? Anyone want to throw out like how they organized the methods in secret diary? What about Aidan? You're in the middle of my screen. Aidan, you and your pair.
Well, we put lock and unlock in like the same block, and then add entry and get entries in a different block. Cool. So you'd have lock and unlock, I guess, first, and then follow as like a prerequisite to being able to add and get entries.
Cool. And if we're using classes, we'd have to find a way to break this one class into separate classes, right? Yeah, with those responsibilities. Nice. What about Petro, you were with Jamie, right? Cool, let's go to different pairs I've had from you. What about Josh? Who are you with your pair?
I was with Matt.
Josh and Matt. How did you manage to get onto secret diary example, and what did you think about it?
Yeah. So we put lock and unlock together because you can't really do one without the other. And then we put the other two together, the get and add, because I guess you've got to know what's already in there before you add to it. So yeah. Cool.
This one feels like it's probably a little bit more straightforward because of the names of the methods. You have lock in 2 and entries in 2. So it feels like there might be something there that we can exploit to make 2 cohesive classes that work together.
Oh, I have a question. If you're separating classes, is when you call a method in another class, is it slower than having all the methods in the same class?
Say it again.
So if I separate lock and unlock in one class, and I separate the other one in the other class, and then I have to call the check function to see if it's unlocked or locked, is that slower than if it was all in one class?
Is it slower?
Yeah. Time complexity.
Negligibly so. All right. So there's a trade-off as always, but the performant operational speed is literally a few clock cycles. All right. Okay, cool. So very, very negligible. So think of objects as quite cheap and not worry too much about that for the moment. When we get into like looking through lists and finding data like elements in lists, then we'll get into sort of complexity in that way. But for the moment, there's literally negligible operational difference, right?
So it's OM1.
Say again?
OM1 time complexity.
Pretty much, yeah.
All right, cool.
Cool. Any other further questions before we move on to the next? Cool. All right. So let's have a look at exercise 2 back in your pairs and do exercise 2 first and exercise 3. All right. And then once you've had a look at 3, this should be no more than 5 to 10 minutes. I want to have a look at some examples that you've done for refactoring into 2 classes. Cool. So exercise 2, use a diagram to group the methods. We have a class example, and I want you to split it into 2 classes. and then use them together. Cool. So let's spend 5 to 10 minutes on this, and let's regather before we do the last exercise. Sound good? Cool. Just another 15 seconds. 11. 2, 1, cool. We should all be back. How'd that go?
Okay, I think.
Cool. Again, quite a simple example, but just trying to like get into this sort of mindset of thinking about how do we extract methods from a class, or how do we think about cohesion and using classes as a convenient way to do this. Let's I need to get my thingamajig up. I'm going to share my screen, and I want to see some examples for some people. So I want to, I guess first share my screen again, desktop. And I'm sharing my screen, and then let's do. Anthony, you're first up. Who are you working with?
Sophie.
Cool. Anthony and Sophie. What was your approach? Well, first of all, we go through the approach. How do we actually run this program if I wanted to print out something? So let's say I wanted to subtract two numbers. How would I get my program to do that?
So first you need to create a new calculator object.
Cool. How do I do that?
So let's calculator equal new calculator. You'd also need that work.
All right, hold on, Sophie. What's next? If I wanted to subtract two numbers together, what do I need to do? And then print it out.
Sorry.
You might be on mute.
Yeah, sorry. What did you say?
How would I subtract two numbers together and then print it?
So do the subtract and then put numbers in place of number 1 and number 2.
So what do I type?
The subtract and then the parentheses with the number in the place of number 1 and a number in the place of number 2.
What numbers do you want?
10 and 5.
10 and 5. Like this?
Yeah.
Cool. And then what happens? Then what comes next? How do we print it using our print function?
I'm not too sure.
Cool. So the subtract function belongs to the class, as does the print function. So in order to be able to call subtract as it is, this function has to exist outside of the class. So if I wanted to make that work, I'd actually have to write another function down here for that to be available. If it's inside the class, I have to use it through the class. So because I've created my class here, I would go object.method. Like this, right? Calculated, and this is probably what you might have been thinking, but I was just being very literal in typing what you said. So we have to use the calculator as the way to call this function. And how would I then print it? What do you think, Sophie? If I wanted to use this print function.
Sorry, I muted myself again.
What's going to be the result of this? What's the return value of calling the subtract function? Quite simply, it's going to be
5.
So if we store that in a variable, we know that results could be 5. How do I then use my print function in the same way that you used like a subtract function? How do I call my print function? What's the object that that has the print function? It's in my.
Oh, in your calculator, yeah. So
Cool. So calculator, nice. Dot print is method, and then what do I print?
Is in the actual answer or the result?
The result, because that's the variable that has stored the value of subtracting 10 and 5.
Yeah.
Nice. Cool. Yeah. Cool. Let's run that program and have a look. Go away. Cool. The answer is 5. Yeah. So far, so good. Everyone, any questions on how we just did that? All right. The big thing here is making sure we understand that in order to use functions from a class, we have to instantiate it first using this new keyword, and then we call these functions using the instance. And this is a term that you'll hear a lot of. All right. The instance of a class is what is stored in this variable, because I've called new on the class to create an instance of it. Think of class like a template. All right. We just create copies of it. We instantiate it with values. So I'm using an instance of this class, and then I have access to all of the methods inside of it. So we go back to like that mental picture we had right at the beginning of like a world that our programs live in. This is like a mini world called calculator that I have to, every time I want access to it, I have to say, world, give me this function. All right, run this function for me. So that's what I'm asking. I'm saying, calculator, please run this function for me, rather than having it run at like the global scope. In the same way, I have to access this as the print method now. Cool. Okay, let's go to another pair. We already heard from Euritic, sorry. Safa. Safa, who are you working with?
Working with Lewis.
Nice. We've already heard from Lewis, but let's go with you, Safa. How would you, what was your approach to encapsulating or better encapsulating the program here?
Do you mean in terms of separating it into different classes? Yep,
because we have 3 bits of it. We have add, subtract, and print. How did you better encapsulate?
We thought it wouldn't make sense to separate the subtract and the add from print. So we did add to print and then subtract print into 2 separate classes.
Say that again.
So we put one class with add and then printing the value, and then separate class with subtract and then printing the value.
Cool. So something like, what did you call your classes?
Just class 1 and 2. You didn't give it a name.
If you had to give it a name, what would it be?
Add and subtract.
Cool. I guess this is this one, and then you also had a print function, right? Okay, so this is one approach. Class add has add, and then how did you actually use them then? So if we go through the similar case here, let's say we wanted to use our add, how would we do that?
I'm not really sure.
So the first thing is we have to instantiate it. So rather than calculator, we have to instantiate our class here.
Okay.
Yeah. So let's call this like an adder. We'll call it as is, like add, and then we want to be able to add 2 numbers together. So we use the instance of a class, and then the function name, which is add.
Okay.
And then the same here, we have the print function. So let's have add.print result. Does that make sense?
Yeah, that makes sense.
Yeah, cool. Let's run it
Yeah.
and see how we do.
I had a question.
Hold on. Cool. So far that works. Nice. Yeah. Question.
How come you're not using constructors? Is it because you don't have a load of different functions? You're not abusing the variable by keep running it through.
So the question from Jamie is why we're not using a constructor function. That's a good question. A constructor function is used to initialize a class with initial values. It constructs the object. So when we use new, if I wanted to create a class with initial values, I'd use a constructor and set those values as properties. So let's go into a new file and let's have a look at an example. So if we have a very generic class that has a method that, say, for example, we wanted to be able to call its full name. So for example, we would do something like that person is a new person. And I wanted to console.log person.full name. This is what I want to do, and I want to be able to create lots of different people. Let's say person 2. Let's just use 2 examples for the moment. How would I go about doing this with a constructor function? So I wanted to be able to initialize it with information when I create the object. So for example, I could do something like this is going to be Jamie. Jamie, you're working with Petra, right? Let's say Petra.
Yeah, I was.
Cool. So if I use a constructor function, it allows me to take this data that I'm using when I create the object and store it on that object. So it looks something like this. I would pass in, I give it a name. So this represents the first argument here represents the name. I'll get to full it later. So I'll do this.name is name. So now I've been able to take this argument, this named argument, and store it on the instance. So if I want to return it, I can do something like this.
So is it when you want a permanent version of the class kept?
So using a constructor function allows me to create lots of copies of a class or instantiate it with different initial values. Yeah.
Yeah. No, I understand that, but surely, like I don't understand the distinction of when I would use it and wouldn't. Like normally, I'd use it when I have loads of other, like say I had 10 functions in a class. I was using a variable in every single one. Like let's take our bank account, for example. So I'm creating, each time I create a new debit card and I'm adding money to it, and obviously I want to keep that class because obviously that has my bank account in it and it has how much money it has. But like if I was doing something like the calculator, I wouldn't care if I was keeping the number and not after I've dealt with it and done with it, I wouldn't be using it. And that's how I've been using constructors, but I don't know if that's correct.
Sounds very reasonable. If you need to create an object with initial values, you have a constructor function. If you don't need it, then you don't need to have it in your class. Okay. Yeah. So if you wanted to be able to store information, like sometimes you don't need a named argument, you can just say like, I don't know, we could keep an empty list and just initialize it with an empty array to begin with. It's just what initial values do you need your object to have? If so, use a constructor function. If you don't, not needed. All right.
Yeah, that makes sense.
Cool. Good question. Okay, so we have one way of reorganizing our classes into two according to their add or their subtract away, and there's no right answer here. I would still think these are not cohesive. With the better cohesive in terms of the now separate responsibilities for adding and subtracting, if there were maybe more adding behavior we need to add. But this is still a concern, or still a responsibility that we can extract, right? The idea of just printing, taking information and logging it to the console. So you could probably still extract the print function in both of these. And so if we left it with two classes here, and then created another class, I don't know, like a printer. All it does is print something. Arguably, that's more cohesive. All right, you no longer have print functions or duplicated code in your add and subtract classes, and you encapsulate it in a printer class. Right. Again, these are quite contrived examples, but we're just thinking about these in different ways. There's an argument to be made that we can keep, maths in one class, or maybe we want to break them down in having separate classes. That's both arguable.
So is this actually better than just having everything in one calculator class?
So the question I heard is essentially, if we go back to this example.
Yeah, that seems to me sort of nice and neat and does everything that.
So the question
for now a calculator
comes up is like, what's the difference between having one class and three classes? In the moment, this is probably like what a lot of you are feeling, right? So the points here are, one, this is a contrived example, right? We're really trying to use very simple examples to demonstrate this idea of like what is cohesive and what's not. It's very easy in your brain to look at this and be like, right, I'm done. Like, that's easy. I don't need to worry about this. But we're really trying to think about the examples of if this is like 100 functions, how do we break this up, right? What does cohesive mean? So, right. So think of it less like this specific example, and look at this as a practice to try and think about cohesion. But we'll get to more real examples when we look at or when you start writing your own programs. All right. And as I said before, there's always a trade-off between lots of files for different classes and trying to keep sort of in your head how these classes are interacting with each other. All right, that will happen. But usually it's much more advantageous to have separate files and individual classes with small responsibility than as have everything in one class. When we get onto testing, it'll be a lot easier to test as well and identify bugs. Is that a reasonable answer for the moment, Lewis?
Ed, I had a small question.
Hold on one second.
Yeah, thanks.
Yeah. Cool. Yes, Ritik.
I was wondering if the print with answer as a it needs to have that answer as its argument. So we need to kind of call small calculator, which is instantiated as calculator as an instance of the calculator class, and then say calculator.print, then bracket calculator.add, and that kind of makes it. Is it the best way to do? I mean, I would rather define a function print outside it, which takes any argument whatsoever and just prints it like you were doing. So
I'm finding it hard to follow exactly what you said, but it sounds interesting. So can you say it again? I'll try and dictate it. Or I'll try and write it.
So I would say function print answer and then just repeat that.
And this.
Yeah, exactly.
Okay.
And then remove the print from the class. And then if you have, let's say, let C equals to calculator, well, yeah, exactly. Calculator. And then just say calculator dot add or subtract or whatever 10, 20. And then I can just call print bracket that, and it will already solve it, instead of again calling another thing.
Like this.
Yeah, exactly.
Yeah. So we've removed it from a calculator. So this calculator class is now more cohesive. Absolutely. And then the argument becomes, and there's no right answer here. And I want you to think about not this specific example, but how this might be when we have a lot bigger and a lot larger a number of classes and files. All right. The question becomes, well, what else exists in this namespace? What else exists in this world, in this scope at this point? If we continue to add functions directly into the same world, we end up littering it or polluting it with lots of different functions. So we want to try and minimize it. So even this print function, where possible, we should keep it in a class or in some kind of object that's responsible for printing. All right. Where possible, try not to just have functions hanging out in the global scope. All right. Sometimes when we require, because if we go back to the idea of like our application living in the context of lots of third-party code, when we try and require it and bring it into our project, we're already polluting that sort of global namespace with all the required libraries. So our program should always, where possible, be contained in objects, like the main program object, but then also individual classes. All right. So this, really good question.
So is this the whole encapsulation concept? Is that what it means? It's to like keep things like not in the global mainframe.
Yep. Yeah, essentially taking that complexity of one scope and trying to break it into smaller objects. Yeah. Right, and then we have to think about how, and we're thinking about cohesion. Right, what rule do we do to break things into small pieces? Cool. More thoughts or questions? And I just realized I forgot to resume my recording. Jesus. All right, am I still recording? It says pause recording, so maybe I am still recording. Anyway, any other thoughts or questions at the moment? Okay, let's look at an exercise 4. So this is the last thing that we'll do this morning, and it'll probably bring us to around 11:30. I'll give you some time to work on this. So there's a few more bits of information, a few more requirements for what these functions should do. But there's still things that you'll have to make choices with your pair partner. Keep it simple where possible, but have a go at implementing a set of classes that you think represent the secret diary problem. All right, so we begin with one class, secret diary, with these 4 functions: lock, unlock, add entry, and get entries. Again, keep it super simple, and see where you get to. All right, it might be just implement it in one class to begin with and see how you do. Keep it simple, and then try and break it into smaller bits. All right. So for the requirements, you can see down here, add entry. You just want to pass a string, maybe keep it super simple, and it stores it in a list. And get entries just maybe logs to your screen or returns a set of all the items in that list. All right, keep it really simple. However, if you call in these methods and it's locked, it will throw an error. All right, so have a quick look at in JavaScript how to throw a new error. Okay, so first organize it in one class, then reorganize it into a set of classes that you think are cohesive. And we've gone through the diagrams. So you probably have something that puts lock and unlock together and something that has add entry and get entries together. Any questions before I send you all off again? Yeah? Give me a thumbs up if you know what you're about to start doing. Cool. All right, I'm going to open up the rooms and I'll give you about half an hour and we'll come back at just before 11:30. See where we got to. Opening rooms now. Cool. Give me like a quick thumbs if that also applies to you. Like this is like, yeah, well, maybe. This is like, yes, Zach, I agree. I don't know how to do it.
Yeah, that was our problem as well.
All right. Let's have a quick look at that. That's probably a good thing to do together. Okay, here I am in an empty editor. The question was how to use two classes together. And this is something that we're going to be working on mostly next module. So we're actually just marching ahead at the moment, which is absolutely fine. So let's take a very small example. Let's go back to let's have two classes. I'm not being very imaginative right now. That's fine. Can everyone see that? We have two classes, a bowl, a class, and a vegetable class. Just give me a quick thumbs up. Yeah, some nods, thanks. And the question is, how can we use these two things together? All right. So let's have a constructor function for our vegetable class that literally just has like a type, so we know what it is. I don't want to have anything more complicated than that. And then I'm going to have one a method in here. I'm going to store a bunch of vegetables in my bowl. So in order to store things, I want to be able to have an array to begin with. So let's just say we keep it like this for the moment. All right, so when I create a bowl, I have an items property that's an empty array. I want to add things to it. Let's have a method here called add that just has an argument that I'm going to, whatever is the argument, I throw it into the array. All right, this.items, and I'm just going to push the item into the array. All right, but if I wanted to add like a specific vegetable, maybe I want to do something like something like this, where I just add, let's go, so I wanted to be able to push into here, not just the item, but maybe I'll have a way to do this where I say, rather than pushing anything, I want to only push a carrot. So how do I access this property from this carrot? So I could just do something like this dot carrot dot type. All right, this will always just add carrots to my bowl. All right, so I'm adding a property. This dot carrot is now equal to a new instance of my vegetable. My vegetable just literally all it does is stores a type. So if I want to use two classes together, the way to do it at the moment is just to create an instance and store it in the constructor function up here on line 7. If I want to use it, I now have access to whatever my vegetable can do. In this case, I've stored a type property. Okay, so let's have a look at like this program. I'm gonna have I missed out something? Parentheses. Okay, so I've put this into my node environment. So I now have a class ball and a class vegetable. How do I use these things together? Let's create a ball. All right, I have a ball. At the moment, it has an empty array and it has a carrot. So far, so good. A few nods. Any questions? Just let me pause there. Any questions on what you're seeing at the moment? Just shout them out if you're like, it doesn't make sense to me. What does that do? Why did you do that? At the moment, I'm trying to demonstrate how we can use two classes together. If we use a class inside another class, we have access to it. Zach, this is probably also one just to make sure that you're getting what you need from this as well, right? Because you asked the original question. So make sure I don't go off on a tangent. Okay, so we have a ball. I want to create a vegetable, so it comes inside of my bowl. So I actually have access to a carrot here. And I want to just, at the moment, my items is empty. So if I want to specifically add a carrot into it, I can do something like bowl.add. And now my items has a carrot into it, right? So I've been able to access type from my other class, right? And the way I've used my other class is just by instantiating it inside of the other one. Right, once this, and think of it like a little mini box. If we go back to, oh, where is my, this one. If we go back to this representation, I'll get my pen out in a second. But think of it like this is our ball, and then we also have a vegetable. But when I created my ball, I've said, actually, let's make sure, oh, can I drag this? My ball comes with the vegetable, right? So I now have access to anything inside of this black box. So when I create it, it now has sort of another object inside of it. I have access to anything that's inside that world.
So every time you make a new bowl, it will come with a carrot.
Exactly.
So
we'll create this, when I use the new keyword, this constructor function runs, sets up the object with a property of items, which is an empty array, sets up a property of carrot, which is a new instance of vegetable. Now, at the moment, my bowl will only ever instantiate vegetables with the name of carrot. Right, that's just the way that I've written this program.
Ed, what was the purpose of this again? Could you just explain it one more time?
We're trying to have a look at how we can use different classes together. So if this class now added some behavior, so like, I don't know, color. How do I get access to the color function from my vegetable? Maybe rather than call type, I call color here. And now I'll just add into this list the vegetable color. So it's how I can access functions and properties of another class inside of my ball. Right, so we can now think of maybe we can start composing objects or classes of other classes. Right, but let's not worry about it. Let's just focus on two things together, and then next week we can think about more classes. But this is quite fundamental, so take your time to think about this and write this out and do it. But the idea is we instantiate a class inside of another class. Right. Once we do that, we have access to anything inside of that class. Right. This dot carrot now holds in of itself an instance of vegetable and therefore all of its functions. This was thinking about I think Zach's question about trying to think about how can we use objects together. How can we do this? So if you've got around this problem, rather than instantiating another class, just extending a class, all right, trying to inherit those functions. Some of you try to go down that road. That doesn't actually follow what we call sort of single responsibility, because you're still extending the same functionality. So where possible, we always prefer composition, right, composing objects to inheritance, as a general rule of thumb, and we'll have another look at that next week. But this morning's exercise was thinking about how we can break one class into two according to cohesion, according to ideas of cohesion. More questions or more thoughts on this?
I would actually have a question. On our question about suggestion, like maybe could you just like write like one or two like exercises on this, because I feel like I understand it in theory, but kind of need to see whether I could put into practice, or could you just point us where we could find like, I don't know, exercises like this, or if you could just post like one or two where which I could like practice this basically. Yeah, absolutely.
I've got a couple of exercises that I'll share after this. Essentially, they'll be extensions of this exercise, which you can keep going and having a look at. There'll be the banks, a set of 4 requirements for those methods that you can have a look at. And then there's one other that I'll also share. So absolutely.
Okay, thank you.
You can also do it for your for the challenges you're doing so far on the JS fundamentals, the set of 9 challenges that are out at the moment. You can also apply those principles to anything that you're doing there as well. All right. A really good question to ask, or ask the group, or ask your peer group, is to share like some work that you've done with like 1 class into 2 classes and say like, I'm trying to encapsulate this better. Any more sort of things to look at, and I'll very happily point out some things. All right.
Sorry, have you said what the best way to encapsulate this is?
The secret diary example?
Yeah.
2 different ways. Some of you already spotted. One is to abstract the diary functionality and keep that here. All right, so the diary is now has a cohesive set of methods: add entry and get entries. And the secret diary, all it does is be responsible for locking.
Yeah.
And then just asks the diary to add entries or get entries. So it just forwards the method calls to here. So this is responsible for storing, as you can see on line 3, for storing the entries. And this is responsible for being locked or unlocked. That's one way to do it, right? Abstracting the diary away from secret diary. And therefore, as we were just talking about, you can, on line 17, I've injected, I'm adding my diary into my constructor, like we did with the vegetable. So I now have access to those methods. That's option number 1. Option number 2 is to go the other way and abstract the lock. Right, 2 different approaches, arguably both the same. Right, keep that separate and then inject that here. Yes, Susanna, go ahead.
So Ritik and I did something similar,
nice.
But instead of kind of having a class for the diary and then another separate class to add functionality. We did like a parent class and a child class, and we like extended the functionality. Would you say that that approach is kind of similar, or is it worse or better in some way? How is it different from what you've just shown here?
Really great question. So we're trying to think of like of a way of using objects together, right? That's essentially what's happening, right? Not only trying to use objects together, but trying to minimize duplicating code. And there are two main approaches here. One is composition, and the other is inheritance. Composition means composing objects of other objects, as you see in front of you. Inheritance means extending, means adding behavior and creating essentially a parent, as you said, a parent-child relationship. Where possible, always prefer composition over inheritance. Lots of reasons why. For the moment, I'm not going to go into it. We'll talk about that when we get into the next module, design. In general, composition allows you to keep things modular and small and keeps the interfaces between classes separate. With inheritance, you get into the problem of there's like the classic one of you want a banana class and you end up having like a trolley with a gorilla inside of it with holding a banana because of all the inheritance chains that go on. All right, you don't know what other things have been inherited. So where possible, keep things as shallow. We'll talk more of those examples next module, all right? Susanna, is that all right?
Yeah, that makes sense. Thank you.
Yeah. I didn't see the green tick. Any other thoughts or questions? What you see in front of you, by the way, is simply what the two possible implementations. There's always good stuff that you've done. This is things to think about. The thing that was new in this last challenge was how do we actually use two objects together? So I think this is something that would be good to keep practicing, and I'll share some exercises. Cool. So we go back to the objectives of this morning. The first two, have a think to yourself. If someone asked you, like, what is behavior in a program, would you be able to give a good definition of it? Are you able to explain that a class is a convenient way to encapsulate behavior? And let's start with those two things first. Like, how confident do you feel? Just give the thumbs up if you feel pretty confident, not really sure, and I don't know what behavior is. Just give a thumbs up to yourself. If it's like anywhere like here less than that, think about what's the learning block here, and then like chat to me and we can figure out a way to resolve that together. And the third one, encapsulate program behavior. How confident do you feel based on this morning's activity? Cool. So some of you are here, some of you are there. Cool. Awesome. So I'll show some examples, and I think that will it. I'll also finish the recording and then cut out the bits where you were all just doing some work and upload that. So that should be live by this afternoon, all right? Cool. Okay, so other than that, it's probably almost time for lunch. Good stuff. This is a good introduction to sort of object-oriented design, and we'll do a lot of that next week. So have a think about it, chat to your peer group, chat to each other, and then also reach out to me for more work or more exercises, and I'll share them in your cohort channel. After lunch, we'll regroup in peer groups, have a quick stand-up about what work we want to do for the afternoon, and then it will be continue on with our learning objectives then. Any questions? Any thoughts? Cool. Awesome. All right, well, I'll see you at 2 p.m. Bye-bye.
Thanks.